some problems. There are some things that very impact this quality data, this cost of utility, but we can't quantify and include them in model. For example, subsidy of shareholder and shareholder for all those are municipality, local municipality. Then some of those utilities don't make any investments, so it's not very sustainable process. Then some capacity used, for example, pump stations are too large for amount of water produced because they are built by European money, and if Europe gives us money, we build as big as we can. but the running cost, this maintenance cost is very high, so there's a problem. And also there are some utilities who need to make some additional services. For example, in Riga International Airport, quality for water for these airplanes is very high. So it's very costly to produce water with so high quality. And what can be done next? So NRA can use this to look at the new, for example, those applications for new tariffs. Some 5 or 6 applications is also put through our model, and let's say the model prediction was very good to those new ones. Then next step can be simplified procedure. If your this application for tariff fits in those percent, then it's okay, nothing else is asked. And also regulator can give some ceiling, not more than this cost, which may be some model cost plus 15% or something like that, that can gradually push it down. And at the final, we think the work was good, the results are promising, and also we are working on a model for sewerage. So, thank you, and questions?
Do you have any questions for a very interesting presentation?
I have one question. You using some of the algorithms, neural networks and others.
Yeah.
Did you try to using some popular data mining algorithms, such as random forest, for example, or other classification algorithms for your research?
We look at these classification algorithms, yes, but actually this is not the task for classification. It's task for predicting the prediction model, and this classification doesn't fit. We think that this classification doesn't fit well in this task. So therefore we look at this also, this classification, but we didn't use it. Mm-hmm. Yes.
Mm-hmm.
Do you have any question more? From my side,
yes.
One question. Could you show us a cost model, a cost element you can
Oh,
take,
what
into
KPIs,
consideration.
yes.
Yeah. And exactly. What of elements for costs you take into consideration?
One moment. This,
Yeah,
this
that's
one,
good.
yes.
A lot of okay. And what do you think in this element of costs? Yeah, do you don't need, for example, the cost of water utilization? What it means if the user use water, and for example, this water should be clear in clear station. I don't know. And do you think it is not important to take it in this model? Because it will be other the water. If we use water, it is not so dirty. If the enterprise, for example, use this water, and we need a lot of energy to clear this water.
Yeah. Okay, let's say two things. To get water and to dispose water, used water, yes. For getting water, in all Latvia, actually the water quality is very high, and those utilities don't need a very specific water clearing. What they need to do is to remove iron from water. There is a lot of iron in water, so. But this is all over the Latvia, and it's the same for everyone, yes. So, and the other, this disposal. Actually, this is model for water acquiring and selling to customers. About this water disposal, here, as I told you, this sewerage. This is the other utility. Many times this is the same utility, the same company who sells you water and then gets from you this dirty water, yes, used water. And at this moment we are working on this water disposal part. Okay. And this will be other model, but we are working at this moment on this.
Thank you very much. Do you have any questions more? Thank you very much for a very interesting presentation. It's for you.
Thank you.
And the next presentation, it will be a view to legal information system and legal subwords. And your name is?
My name is Chiras.
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 Vitatus Chiras. Please. 20 minutes, yeah, please.
Yes, I will try. I come from the Faculty of Mathematics from Computer Science Department. My colleague comes from departments of law. And I will speak about the views. Views is a term known in requirements engineering, use of different stakeholders. But the rest lines are not that easy. The term sub-levels I will explain later, but I will speak about legal information. Actually, such systems as national registers are included. First introduction about the meaning of law. I want to start with semiotics and not Internet of Things. If we have a word, let's say law, its content or its meaning is not that simple. We have heard three interpretations of the word Internet of Things in three invited talks. Each was different. And I think for Internet of Things is different in each of your heads. The same as me. And I want to speak about complicated phenomena and about its representation. So I continue about another sign which is similar to John Sova. I have taken picture from him, but the rest is me. If I communicate the word, let's say the word law, again, a lawyer understands one way, computer science understands another, scientist understands another way. In case this is not the word law, but let's say a cat, it's more simple to speak, and therefore we have so-called semiotic triangle. This is semiotic tetrahedron, but of course I have taken pictures from one report which appeared something like 10 years ago. But the semiotic triangle appeared 100 years ago by two Americans who wrote the book, The Meaning of Meaning. And this book is usually cited by people, not only in computer science, very rare, but in semiotics and lore. And the picture, picture is here the same. If we have the word cat, this is a cat, a proper name, then it's easier to understand and to communicate. But if we have Internet of Things or law, this is quite complicated, and therefore tetrahedron is a more recent concept. It depends on the viewer, on stakeholder. Actually, there is no, if we have idea, we have representations, and computer science will speak about this representation. That's what computer scientists and knowledge representation deal with. And again, if we have an idea, we have representation. But what about idea for the word law is very complicated. And the report, this is a report was supported by authoritative organization, written by Germans, people from Netherlands, about 10 authors. So this was introduction. So you see, it's more about, let's see, semiotics, or I'm interested also in philosophy of law. And the next introduction, that will be about the view of people who work in the domain of law, how they view law, the phenomena. They say we have 8 views. Views means, again, view of stakeholders or different representations, and first proposal is to have 8 of you. I am not sure that there are no more of them, because as in each domain you can invent stakeholders or classify to smaller groups. So the first text corpus view is texts, and they are usually now in internet and so-called in cyberspace. But the rest are very important. The second, metadata, is important for legal informatics, because in search engines you can search according to metadata and not to pure words like. But the rest are also interesting. I will speak later in more details. I do not want to make it boring you. For example, lawyers are interested for this, and to find proper documents to cite. This is especially important in American law. In continental law, this is not that important. There are specific legal methods that are not known for computer science, and therefore the products are quite different what we could imagine about text corpus view. There are commentaries. They might be electronic, some are, because the knowledge of experts is also a source of lore, not only printed, not black lettering. The same as other cases. Case-based lore is especially interesting in America, but nowadays in our countries. About term sub-level, I might define this as a, okay, did not change the letter. This is sub-level is a level of infrastructural services. In case domain can be divided into subdomain, this is what is common. The picture, this is informal description, and explanation is also taken from the view of Zachman, who also had a similar two-dimensional matrix. One line I understand as a sub-level. If you know Zachman's framework, it was 30, 40 years ago, I think. In the legal domain, we have agreed that legal ontologies, all this stuff which deals with metadata, might be a meta level. Lawyers do not know how to structure it, but this is. Actually, the terminology, or legal terms, was identified as a kind of sub-level because it has nothing to do with normativity. Actually, law does with normativity, but pure words, they are not normative. You can take a dictionary in Chinese or saying they are not normative. You can treat normative because of writing rules. Commentaries, another sub-level, and I mentioned the first sub-level is simply legal text, but legal texts are not that interesting because only computer scientists might thought, oh, black letter law, this is important, but the lawyers know more. And why the meaning of law is important, why it is interesting for me? Because of compliance. I have enjoyed one paper by an author from Switzerland who formulated very in elegant form. Drawing is mine, but the words are his. Suppose we have law. We obtain legal requirements and build a system, let's say a tax declaration system. We call this legal machine. Because its action have legal consequences. This is like traffic lights. Red lines means if you cross, you are guilty. The same here, if you declare taxes wrong, you are guilty, but you can't go loops. This is not reflected. And again, the story is that software engineering design and implement the system compliant. However, the question is it compliant with law? And in general, no, because it's impossible to derive all kinds of legal requirements. And I also enjoyed papers by German authors from company SAP 2-3 years ago, four, where they have provided examples about apps here. And they have shown the very hypothetical case where the user says, yes, I agree, but they show his agreement has nothing to do with legal agreement, because he is a weak side of a contract. He does not understand the content, especially children and young, and so. And this was, in their paper, there was a hypothetical example, but it also illustrates the whole complexity of law as phenomenon. Again, because requirements are derived from, let's say, communication law, and legal regulation of all that stuff. But requirements from contract law, tort law, and criminal law, they can be hardly known for a person who formulates this. And this usually occurs also in law. Let's say in the parliament the law is passed, but constitutional court formulates a verdict, let's say 5 years later, that this or this line is not compatible. And therefore, so-called constitutional courts serve in each country. Though the story is not that similar, but there is no solution to formulate requirements to take all aspects of law as phenomenon. And about views. Okay, I have said one view is document view. These are texts. Another are already legal concept. Some concept can be annotated in metadata and searched because in the search engine, not in Google, but in legal documents search, there are more concepts. Citations are a big field to explain. I don't want to go into the details. And the queries about users, this is more familiar for computer scientists because the users who query are also registered. This is part of so-called big data. Now I could run quickly about each view, but this is not that interesting because you are not in this domain. Again, document view, so-called annotation view, so-called citation view. This is long story again for people who work in legal informatics. Logical view. Okay, a few. We know that first export systems were designed 40 years ago by Marek Sergo, implemented British Citizenship Act with rules, and this was widely publicated in ACM and cited. Now Marek Sergo is not that young at that time, but he has white hair, the same as his colleague. And all the concept as they have implemented that time, implement law as rules, is very criticized nowadays. One of the criticisms was, again, in my picture here, that you can take law and give, let's say, British Citizens Act as rules. No, it does not work, actually, because the law representation one has to be different. It has to be model the situation of authorities which give permissions, let's say, in case of that. And this is not that simple as to give rules. You can explain rules for a child, but if you explain rules representing them for a machine, nevertheless, machine does not understand the games. In order to understand the whole game, let's say chess, moves are not enough. And ontological view I have skipped. I do not want to spend details. And my conclusions, the main conclusion is that I am presenting exploratory research, no application. I do not know what is the best list of views and best list of representation, but surely not the list of black letter law. This is like usually computer scientists saying that I will read what electronic signature is and I will use this. But my colleagues implement nowadays, let's say, electronic signature, work-based bank, but I'm not sure that all these applications are without bugs. And the stores are taken from financial management, where the banks, like in America, went bankrupt. And they were not compatible, the system, with law, actually, intentionally. That's my story. Thank you.
Thank you very much. Please, do you have any questions? And from my side, what do you think? It is, I think it is a very difficult subject, but if governments in Lithuania, Poland, I don't know, in Germany, formulate law as a set of rules, the law is formulated as a set of rules, but it's very complicated. It is possible in the future create a system that first support the verdicts in law. What do you think about it?
Yes, lawyers are skeptical. They say, no, this is impossible in general case. This was discussed in legal theory. And that is the following. Standard cases should be decided by computers. Like traffic radars. Yes,
Okay.
you see, I received the letter, please come and explain. You can argue that he was busy or was driving too fast because he was taking your wife to hospital, something like that. This is later, but this is another phase of business cycle. But standard cases, yes, that's the work of legal expert systems. Okay, now modeling approach. Hard cases, no, discussed in legal theory and even in international. In European courts, the court raises verdict, but separate lawyers can have separate opinion. Opinion is printed and you can read internet. But the law has made verdict. This is normative. You have to obey it. The same in our country, the courts. Verdict, you can go to second instance. Appeal. So this is not possible, lawyers say this is not possible. I do not want to discuss because I have written about this.
Yeah, okay.
Because you have fact, you have rule, but interpretation requires intelligence. If you kill the people, it means nothing, probably misconduct, probably self-defense, and this is, I have slides, but not for today, sorry.
I think it is very interesting. Maybe it will be interesting if, for example, we have a judgment, and one of the vote in the judgment is a computer system, come from computer system. Maybe it will be interesting. We have, for example, 12 judges, and one of this is a computer system. Yeah.
You want too much, this is general idea. People want too much from computers.
Yeah, of course.
Yeah, for your life it's enough to make, or let's say, selling machines, semaphores, tax declaration. But why do you want to expect to go in the domain of medicine, law? Okay, surgeons you cannot operate via distance, but okay, but not the verdict of concilium. So, of course, yes, early expert system, that was the failure of Dendral, also discussed by the course.
I'm sorry, very interesting presentation. Could I ask you to say a little about ontology?
Oh,
A little.
I read usually a course and use materials, very serious materials. What is ontology by German authors? And they explain what is ontology. Ontology is a legal, ontology is a logical theory. That means theory. What are the atoms of theory? There is alphabet, and alphabet is mapped to terms. And that's very short. I do not want about pragmatics of ontologies. There are trees of so if you ask me what is ontology, I usually answer. I cannot answer in short. I have to take this article and to explain, because this is a logic, this is theory. This theory can be big or small depending. If you speak, and in the article they speak about, let's say, employers and so on. And if you want to include that employer has a pet, that would be your theory. But usually they say that employers are students and teachers.
Thank you very much.
I spend more time.
Thank you very much. And, of course, a certificate for you. Sorry. Congratulations.
Thank you.
Okay. The next presentation, it's me. Okay. I work in, I come from Jonagura, University from Jonagura, and I work in Institute of Computer Science and Production Management, but in Faculty of Mechanical Engineering, not Informatic. And, but all my, not all my life, but I have last 20, 25 years, I work with computer system, especially with enterprise resource planning systems. And first, for my presentation, a model of an ERP-based knowledge management system for engineer-to-order enterprise. I'd like to maybe explain what means engineer-to-order enterprises. We have a lot of kind of production. For example, automotive production, it is typical make to order. I go to special players, or I want to order a new car, and I say this model, this kind of color, and so on and so on, all my wishes, and after 8 weeks, maybe 2 months, I come to me my car. because this car is made for my wishes, made to order. And we have a lot of enterprises that produce for make to stock, ketchup for example, or I don't know, all PepsiCo and so on. This is product for make to stock. But a very interesting area of enterprises is engineer to order. Engineer to order companies, it is this production approach. One is the company designs and manufactures products based on very specific customer requirements. It means if I want to build a new production line, I come to a special enterprise, and this enterprise, this company, design for me this production line. If I sign the contract, I have no documentation for this because I get a quite new product, quite new system, and in a lot of cases, the new system, it is prototype. The engineer to order production is dedicated to the manufacturing of short series, and this is or individual prototype products or technologies. It means I can order maybe 100 special windows, and it's wish, for example. The management of the system, for example, near my right company, the production cycles for this product is about from 6 months to 1.5 years. The products costs about €1 million or more, and that's all about this kind of production. Uh, 15 years ago, I participated in implementation of ERP system in this company, and it was very important to support the project management and the processes, concept of products, product design, technology, production planning, manufacturing, and so on, all areas to support with the systems. And we have successfully implemented this system. Of course, in such company, the implementation process is this is never-ending story. It's always something to do, but in I think 2003 or 2004, the implementation was ready. Generally, I think it means the company use ERP system in all areas, from financial, human resources, to production planning, manufacturing, product design, and so on. Use this system and, of course, generate a lot of data. This is 12, 15 years. It means terabytes of data are generated in this period of time. And the question is what we can do with the data. Because, and the very important question is, or problem, how to transform the data or information that are in this ERP system, or from the ERP system into knowledge for effective product development and project management improvement, for example. Is it possible or not? How we can analyze the data? We are on, I have to say, we are on the beginning of the process. Yeah? We start with the process, but it is, of course, not only for a problem for this enterprise. It is generally a lot of enterprises in automotive branch and so on use ERP systems, and in my opinion, from my experiences, I can say that the systems, very expensive, are used only to register the data and to support operation processes. Yeah? If I buy materials, the materials come to me, I register, and I give these materials to production. I'm very happy. I have all in my papers very correct. Yeah? But the question is how we can use the enormous quantity of data to support the systems, how we can transform the data, the information from the systems to knowledge. Because it is a lot of know-how in the systems. And we can try to first to prepare a methodology of data transformation. First, we have to separate what of data we have we take into consideration. For example, materials indexes, bill of materials, designs, variants, technologies, machine tools, projects, schedules. This is all information about the company, but for example, maintenance and service, quality protocols, complaints, inquiry, offers, sales, all from marketing, distribution, cooperation. It is, and we have to try to find relation between the data, and we try to build rules. The rules, maybe we can transform to a form of knowledge. The data, and first we have to start with data analysis and interpretation. What means the data, and what is the influence of the data for the processes, business processes in the enterprises, and for example, what will be influence of the data for the processes in the future. Next, classification of information. Yeah. How we can classify the information in 10 years or 12 years, 15 years. Yeah. It is possible, for example, classification information about personnel of a company. Yeah. Next step will be creating rules of inference. And his acquisition of knowledge, knowledge modeling, but we have here the flop decision, and here we have to, I think, build a decision support system based on the well-known methods, I don't know, SMART or HAP method. On the end of this process, we should get a knowledge representation which we can implement in a knowledge management system. We've started with classification of data sets, which we take into this, for example, it is examples of some areas of enterprises, for example, sales and distribution, inquiries, offers, orders, invoices. It is a lot of data from last 15 years, and we're looking for relations and influence for the business processes. For example, market research, offer preparing, and so on. For example, it is a very important thing, and who know how long the offer was prepared 10 years ago and how long the offer is prepared in this moment with the system and so on. And what we can, it is very important because nobody pay for offer. And if we want to sell 10 products, maybe we should send 100 offers. Yeah? It means our people, our personnel, not in sales department or in construction and sales department, because it is, we don't sell bread or milk, we sell very specific high performance, high tech, and it is to prepare an offer we need sometimes 1 month or 2 months. Okay, we have the data sets, Of course, if we take production roads, it is a lot of, it is only a data set, but it's in the tables, it is a lot of different examples of production for the 15 years, for example. How different products was produced, not only in our enterprises, for example, but only in cooperation with our partners. Next, we want to build maybe simple and more complex decision rules. For example, very simple rules that we will use in the system. If a customer has overdue payment, 30 days, then a new offer cannot be prepared. It's very simple. We can implement it and these rules are implemented in our system, because marketing cannot send an offer if this customer don't pay. And the next, if inventory level of material or minimum maximum level of material, then the order material is sold, and so on and so on. But in next step, the interference rule, influence over data are created. For example, if bill of material, it is a specification of all material for the product, is used, then the technology should be applied to minimize manufacturing costs. It means it is the support system for designer. It means if I take this part, automatically the system gives me this technology or the list of technologies from the cheapest to the more expensive, or most expensive, and so on. If production variance, it is only there are only examples of rules. On the base, next step, we have prepared a concept or a model. Maybe it's not model, a concept model of the system. We have the business processes, data processes, from a lot of relation with suppliers, with customers. And we have this database to prepare or to transform the data to knowledge. We need first the data analyzer. We have to create a data analyzer to take the data from the ERP system and to interpret it. And we need a next tool, data relationship, the next tool to looking for relationship between different data, but it is not so simple because we have to create what of one day, we have to create a topology, a system, we have to create something as a structure where we can say, okay, we have data and what the data have for influence for the other data or for activities in the company. And it is, I think, very difficult to film. Of course, we need the information classifier, and on the base of the free tools with knowledge workers, the people, engineers and people who are from the company, which know processes, products and so on, we can, and experts, we can make inference rules, decision rules, and in next step, with knowledge acquisition, knowledge modeling, and knowledge representation, we can build the model of knowledge system for the company. This is an example of procedure of knowledge management for product development. First, we have concept, product concept, and for the product concept, we need rules and special data sets. Next, we can scope the project, and next, what we for data sets we need for this scope of project to determine the scope of the project. Next step, we have to prepare schedule of the project, next data sets that we need for it, and so on. On the end, this is only the procedure to prepare the prepare a new project, new order, new order to and implement it in production. And on the end, we should get selection of the best variant of the project, or the set for a short list of a project. For example, three possible variants of the product. In conclusion, I'm sure that ERP database is very important knowledge repository. This, I think, and it is big potential, and I think nobody in this moment, maybe not nobody, but not only some companies use it for as a knowledge repository. A lot of majority of the enterprises use it as a database, only database. Next, model of knowledge management system dedicated to ETO enterprise is proposed. Its concept of the model is the model is based on transformation of data from ERP system using interference and decision rules. And the procedure of knowledge management is also proposed. We develop this procedure, of course, with the company. And decision and inference rules should be created by experts or knowledge workers of enterprise ETO company. That's all. Thank you very much for your attention. Maybe you have any questions for me.
I have a question. I think it's a very challenging topic in general. So you have got products where you are selling it to a customer, and you are not really now all the constraints when you are selling it, probably because you need the time to produce it. You have got very many variants of your product because maybe the supplier changed the parts they are delivering, or they can't deliver it anymore, so you have to make a replan. So you got to update your complete ERP line in general. So how do you manage to get the best variant when you got change within your systems when you're producing it?
I think one in the system, the ERP system, realize the properties well. I think in this moment, and the people, the processes in the company, I think it is are not optimal. I cannot company where the processes are optimal, but in my opinion, the system not support, for example, developing new products or new technologies. And for example, nobody in this company have research and design department, and they work with in new methods, new processes, and so on, but they don't use the ERP system and the historical data. And I think it is a lot of potential, because 15 years, it means a lot of people don't work more in the company because they are too old, but a lot of experiences is in the system. And I think it will be good if we prepare a system to support the, for example, product development or for this system. I don't know if
Yeah,
they
I
are
think that's
satisfied.
a very promising approach in general. So using the ERP system as well for development aspects or deriving new products from it. So you got new variants. I'm one of the variants.
For example,
guy.
but the designers here, they make a lot of variants of products. Yeah, and in this company were about, I think, in this moment, 100 or 150 designers. Yeah, if come new project, new and the team of designers is dedicated for this project. Yeah, and they have no time to look what the other teams make, for example. Yeah, because a new project comes and comes and comes, and they have only time to create this project and so on. Yeah, and the problem is how to use the big database and, for instance, to communicate, for example. Yeah, but it is not so simple. Yeah, how?
I think you got the last slide, the one before, said that the last step was the selection of the best variant of the project.
Here?
Yes, the last step, selection of the best variant of the project. I think this step is very challenging because you've got so many constraints within all areas. You've got hardware aspects, you've got software aspects, you have design aspects as well as several other things.
Of course. But, and the three steps scope. The scope is determined by customer. Schedule is determined by customers. This is determined by customers and us because we have a limited budget of a project. But for one product, we can get several different variants, for example. Yeah, and we can select this the best variant. But for example, all these variants are prepared in ERP systems. So and maybe and we have, for example, 10 different variants, very general variants. It's not documentation. This is only because you have to understand 10 variants, it means general variants. We have no documentation, no construction documentation. It is generally description of a product. Yeah, what functionality of a product and so on and so on. It is because it is engineered to order. If we sign the contract, we start to prepare the documentation. Yeah, but here we have only general concept of our product.
I think that's quite okay, but I thought that the best variant of the project, I would get around about 1 million variants because of the many different parts within a product. So it's not that complex. It's complex because you have got to choose within those two variants which are high level.
But you are right. For example, they use old products and they use the old constructions and so on. They take some elements from and it is very important part of our of the system. How to support the, for example, the people who prepare the offers. What we should use, what for solution we should use in this new product. Yeah, but it's only one aspect of this work. Yeah.
Thank you.
Thank you very much. Do you have any questions? And the next. The next presentation. Cloud-based enterprise information system, determination of adoption in the context of organization.
Sorry.
Yeah. Center.
Thank you. There is no USB port here. Ah, I found that.
And hello all, I am Umut Şener. I am working as a research assistant in the Faculty of Informatics, the Middle East Technical University in Turkey. And I got my master degree already, and I am new starter PhD student at the same faculty at Informatics. Now I will present my study, which is entitled as Cloud-Based Enterprise Information System. We investigate the determinants of the adoption in the context of the organization. So this is my outline of the study. First, I will give some brief introduction of my study. Then I will briefly explain my literature review. Then I will explain our research model of the study. And according to the research model, we have included some factors that affecting the intention of the decision of the adoption of cloud-based enterprise information system. So we ranked all the determinants and we prioritize the determinants of the adoption influencing factor. Then I would like to finish with conclusion my presentation. So first, I give some brief information about my study. This study aims to investigate the determinants of the cloud-based enterprise information system, but in the context of the organization, not individual level. So first, we conduct a literature review, which is proposed by Kitchenham. We follow the steps proposed by Kitchenham, systematic literature review method, and then we select a baseline study of the TOI model, which is proposed at the 1990. And the TOI model, it refers to technology, organization, and environmental model. We select this model as a baseline of our study, and then we employ analytic hierarchy process to rank all determinants and to prioritize the determinants among the groups. So the main contribution of the study, first we determine the influencing factor for the adoption of a cloud-based enterprise information system, and then we assign a weights for each factors. Then we give a guidance for cloud providers, service providers. So let's see the literature review. First, we review main concept related to cloud computing and enterprise information system. Then we review the intersection of these both area, which is cloud-based enterprise information systems. So as you know, cloud-based has three service models and provide infrastructure, platform or software for the enterprises, and enterprises implements cloud-based solution due to its advantage, such as flexibility, availability on demand, and pay-as-you-go service model. And enterprises also implements enterprise information systems. For example, ERP, CRM, SCM is the most common, most popular enterprise information systems, and enterprises implements these systems, but traditional enterprise information system can be heavy, complicated, or expensive for most organizations. Therefore, enterprises start to transfer to the cloud-based enterprise information system to encounter this problem, as I stated. So have a look at the cloud-based enterprise information system. In this study, we refer Cloud EIS, which means Cloud-Based Enterprise Information System, which is more flexible enterprise system than the traditional one, and integrated with cloud computing and accessible via the internet. So it has many advantages, such as it is cost-effective approach. So you don't have to buy all entire system. You can only buy relevant function module, and it is more flexible, and you can assign non-core function to cloud provider. The enterprises can focus on the core function in the businesses, and they can also implement the cutting-edge technology at a reasonable level, as I stated before. So there are many advantages for the cloud-based enterprise information system. Therefore, we want to investigate what is the determinants of the adoption of such a systems. So therefore, we first investigate the related theories. Actually, the theories related to adoption of an innovation technology, since cloud-based enterprise information is a new technology for today. So we will investigate all the theories. The first one is investigate the adoption at an individual level, but technology, organization, and environment model investigate organizational context. Therefore, we select this theory as a baseline study of our research model. So we can make a detailed look for the TOEI framework. As I said, TOEI has three contexts, which is technology, organization, and environment, and it provides comprehensive viewpoint of the enterprises and inner and outer dynamics of the enterprises. And it seems that it is reliable and applicable to various IT adoption studies. Therefore, we select this TOEI framework. So we propose a research model for the investigating the adoption. So we propose this approach. First, we conduct a literature review, and we select our baseline study as a TOEI framework, and then we searched studies on 3 websites, which are Scopus, ISL, and Web of Science, and then we get 949 journals, and we review all journals related to cloud computing and enterprise information systems. After elimination process, we only get 29 primary studies. These studies contributes our research model, which is we create this table. We state the most significant factors that influencing the adoption of the cloud computing-based solution, and together with the corresponding orders, and we categorize these factors into the 3 contexts of the TOEI framework. And these techniques, we get the weight, and it is found as easy and efficient. So for the ranking of the factors, first we determine the most significant factors from literature, as I said before, and we find the scale of the matrix. So we select the Satie scale. As you can see, 1 refers to equal importance, where the 9 refers to extreme importance, and we have intermediate values. This scale actually covers linguistic judgment into the measured value, like from 1 to 9. So this is our judgment matrix. For example, these responders say that, first of all, the responder have to compare pair-wise of each item. These responders say that relative advantage is to them trust, because he votes that 1/5, but relative advantage is moderately more important than complexity, because he stated that as 4. So the yellow area is voted by the responder, and this is the pair-wise comparison method, and the responder have to finish all these yellow area according to his opinion and his experience related to this adoption domain. And after that, we will obtain the weights of each factor. For example, these responders say that trust is the most significant factor that affect the decision of the adoption cloud-based enterprise information systems. But he say also that complexity is the most insignificant factors that affecting the adoption. And after calculating the weights of each factor, we have to check the consistency of the survey. That means the responder can randomly assign a number for the comparison matrix. So we have to check the consistency. In this example, consistency is 7%. So the consistency should be under 10%. So this is our comparison item. For example, in this example, technology, consistency of the technology is under 5%. So that means there is no inconsistent response. So the survey is consistent. So all comparison item is under 5%. Therefore, we can consider all the responses from the experts. So after that, we obtain the weights of the factors. First, we obtain relative advantage, trust, and other some factors. And then we have to calculate the global weights of each factor. For example, for relative advantage, I have to multiply the local weights of the relative advantage with its parents' weights, which is technology. And I multiply with local weight, and then I can obtain the global weight of the relative advantage. In this way, we calculate all the global weights of the factors, and then we normalized the global weight, and then we made a priority between these factors. So results show that security and privacy is mostly affected the decision of the adoption such a cloud-based enterprise system. That means if a cloud service provider offers a high level of security and privacy, the enterprises will be more likely to adopt such a system. So cloud provider can encounter these security and privacy concerns by enhancing the security level of the product. And the second important factor is seen as the business activity and cloud EIS fitness. That means the fitness between the organizational culture or primary study or supported activity of the enterprises between the cloud infrastructure, cloud architecture. If the fitness is well, the organization will be more enthusiastic for the adoption of the cloud-based enterprise information system. And the third one is top management support. Since the transferring from on-premise enterprise information system to cloud-based solution is a strategic decision, and executive of the enterprises is usually actually the top manager of the enterprises is very important for this decision. If he supports his employee to transit a cloud-based solution, or if you're aware of the benefits of the cloud-based solution, he will assign more resource to transit cloud-based enterprise information system. Therefore, the top management support is seen as the most important factors. But there is interesting thing is that the complexity of the cloud-based enterprise information system is not seen as so much important. Although he is affect the adoption of the cloud-based enterprise system, the complexity can be omitted if the cloud-based product, if the cloud-based, for example, if a high level of security and privacy product can be seen as the most important part, but the complexity of the product can be omitted if the other requirements is satisfied the enterprises. So enterprises except that we can make a more effort to learn and utilize the function of the cloud-based enterprise system, but if you provide a high-level security and privacy level product. So at the final stage, we conduct a t-test because our sampling consists of the 20 experts, 10 of them from a PhD students and 10 of them an experts from a company, they are mainly IT specialists. So if there is a significant differences between PhD students and experts, we conduct a t-test, and t-tests show that there is no significant results, and the significant and risk factor are not significant to affect the decision of the adoption. So finally, the conclusion. So the aim of this study is investigate the most significant factors that affect the adoption of the cloud EIS, and we provide a literature review about the cloud computing and enterprise information systems adoption, and we developed a research model, and then we form a hierarchical structure of the factors based on the TOEI framework, and we employ AHP methodology to perform ranking process. And the contribution of this study, it provides the systematic literature review, and it provides some insight for the researcher and practitioner as well. So also it provides a guideline for a cloud server provider. But the limitation of the study is number of responders. We are planning to make bigger sampling for the AHP survey. So that's all. If you have any question.
Thank you very much.
Thank you.
If you have any questions. Maybe first from my side, if you looking for determinants that or factors that determine why enterprises should use information system on the base of the cloud computing, yeah, or not? You're looking for the answer of the question or not?
Actually,
Yeah,
actually we are looking for which factor are affecting the decision of the adoption of a cloud-based enterprise system.
What is the most important factor for
Yeah, among them, after all that, we determine the factors, and then after we determine the most important factor that affect the decision of the adoption such a system.
And what is the most important factor in this on the basis of your research?
Yeah, security and privacy is the most important factors. So it can be inhibitor or exhibitor for the adoption decision. So we prioritize the factors. The most important one is security privacy. And the last most significant factor is complexity. Insignificant, sorry.
That is, from my side, I think the complexity is, I think, very, but you don't take into consideration the prices of the system? No, it is not interesting.
No, because we think that the factors affect the decision, but the price also can be considered, but it should be assessed independently. So therefore we don't consider the cost of the system. Yeah.
Okay, thank you. Yeah, please.
It's really nice research. I would say that maybe you could make to take more participants in your research. It would be nice to place on internet all this framework with ability evaluate my organization, my cloud solutions which I would like to take, and in such open source manner you can accumulate more information, I think. And now those priorities in reality looks really interesting. Security and privacy, I don't have anything. It's clearly very important thing talking about cloud solutions. But second and third one of top management support, it's really, I'm not sure, is it in reality?
For example, in implementation of ERP systems, this something. Yeah? If you the most important is support of top management. Yeah? Yes.
Because the transition of the cloud to cloud is itself is a strategic decision, and top manager affects this decision as well. And the top manager also, the support their employee to transit cloud, and top manager can hire and high level required IT specialists to transit such a system. So top manager very important.
Okay,
Actually,
we have only time for last question. Yeah? Thank you. You have you a question?
But it's not important. Oh, okay. You used questions. You asked questions to the people, yes?
Yeah.
Those experts.
expert, yeah.
Those experts are from different institutions, yes? Which are using this cloud service or not?
Actually, the experts is the IT specialist. Some of them use cloud-based enterprise information system. Some of them only working with the enterprise information system, but not cloud-based. So we only consider...
That experts tell you, for example, for this system, it's important to be security or something. They don't use the system. They only say you that these parameters are important.
No, they only actually they use at least one enterprise information system. But we say that if you transit to cloud, what is your consideration? And they say that security and privacy is the most.
But as they don't decide to buy this cloud, yes, for now.
Yeah, for sure. So we just investigate the influencing factor. We are not investigating.
Thank you very much for the very interesting presentation.
Thank you.
And now we have the next presentation. Excellent. Last, not the least, I think. Semi-supervised learning approach? No. Oh, or yes or no?
This one?
No. The last is rule-based canonicalization of arbitrary tables in spreadsheets. Please,
Okay,
we have only 15 minutes.
I'll try.
We can do it.
Dear colleagues, the topic of my talks is rule-based canonicalization of arbitrary tables in spreadsheets. In our life, we often have a deal with different tables. It's such kind of reports of such kind bills and a huge amount of databases. So the word of tables we can represent in two subwords. This is unstructured table data. This data is understandable for human, and they are represented in PDF documents, spreadsheets, some different text, and so on. We can read, write, and edit this kind of data. And the other word is a word of structured data. This data are presented in relational database, for example, and we can query this data and analyze them. If we want to get some unstructured data from structured data, it's very easy approach. We can do a query and save this query as a document, and so we can process them. If we want to get structured data from unstructured tables, it's a very hard way. For example, we should to get this data, to analyze the structure of this data. If we used optical recognition information, we should create a correct representation of this information. We should clear data information. These errors of errors in data maybe connect with optical recognition errors or some misprints, mistypes, and so on. And as a goal, we want to create canonical forms data, and this data we can process and upload to some databases with the help of different ETL systems. So what is our purpose? Globally, we want to automate unstructured tabular data integration. When we have a different tabular data, and we want to prepare them for uploading to databases. Currently, we are on the way to our goal, and currently we try to automate table analysis and interpretation. All tables are different, and for example, example of table represented on this slide, and we know that a table has some structure, different structure for different types of tables. Table may have some style settings. For example, when we have deal with PDF documents or Excel or HTML data, and the table has a textual context. For example, some labels, some marks. If we try to present the table of every entry labels, labels categories, we can show that it's very hard to process it. So when we know semantics, when we can get semantic representation of this table, we get some labels, some textual information, some categories, and this representation is ready for process by ETL tools. Well, what challenges on our way? There are too many layouts to create tables. Because of anyone who create tables can invent new one. Messy data with some typos, correctness, and so on. And some marks is made in natural language. So it's hard to understand these marks just. And what is our idea? When the user creates a table, he uses some rules of table generation. Its own rules, however, he try to do it. And the tables of one user. It's maybe a company, maybe government agency, maybe some company. They have a similar structure, style, and context of representation. And then we can define some rules for tables to analyze and interpret them. And after that, we can use a rule engine to execute these rules. For this analysis, we create a domain-specific language which is based on rule language, and we can describe these rules and execute them in rule engine. The description of rule is represented on this slide. If we create a lot of rules, we can create a lot of tables. And if we note all types and all structures of the table, we can process it more correctly. This is a representation of left-hand side of rules. It's types of cells, entry, label categories, and some of next slides will represent an approach for tables and cell description. For example, if we have splitting cells, we should use rules to merge these cells. An example of merged and split cells in the slide. We should use and should describe rules to cell making. So we should some rules to point the end and or the start and the end of the table. We should describe types of entry creation and label creation. And sure, we should describe a label categorization. If we have label association, we should describe them also. And label grouping and entity association, and some data associated with another data. As a result, we can generate a canonical form. So we do a canonicalization of the tables. And this table is able to upload to database and process, and we can use it for aggregation data from different sources, and we can use it for different data analysis. A lot of table, a lot of data representation should a lot of rules, and for example, we should correctly process some critical cells. For example, presented on this slide. Some headers have label groups, and we should process this. And some labels have a label hierarchy. For example, it's maybe tabular symbols or blank symbols, and we should process them. To specified categories, we suggest to use YAML language. It's more simple, and we can apply our domain-specific language, CLR, for detection names of the categories. One type of the table may consist multi-valued values in one cell. For example, these multi-valued cells which use Chinese hieroglyphs, and this is a representation of this table. Some data have a footnotes, and we must determine these footnotes and connect them with the data. And if the table has some colors, we can use this information for the type of file presented on this slide. If briefly we have some table or data in spreadsheet format, for example, in Excel document, we have category description in YAML format and CRL rules. And when we upload this information, at the end we canonical representation table in Excel format. We did one experimental evaluation. We used a Tango dataset for our experiment. It consists of about 200 different tables, which collected from 10 statistical sites and in 2009. The tables we divided some groups. Groups and categories of tables depend on the data representation in the tables. And we use some measures, as I recall, and precision to estimate our technology and our approaches. And after that, our prototype processed all the data. Two experts compare the sources and result tables, and if that experts have some an agreement, the third expert get a table decision. And this is the result of data interpretation. We processed 200 tables with recall of 87% and precision of 89%. If we have some incorrectness, we decided that that table was not processed correctly. If we compare our approach and our technology with other, this is illustrated in this slide. So our approach, our methodology is mainly oriented on unstructured tabular data integration processes. We expect it to be very useful in the case when the data from a large number of tables appreciating for a few table types are required to a population database. One set of rules can be suitable for processing a wide range of another of different tables. So we don't use one rule for one tables. We can collect these rules, and if we have a lot of rules, we can process a lot of tables more correctly. And our experiment demonstrates that narrowing of table can cause simplifying for rules and increase of call and precision in table communalization. And this slide presents our further plans, our further works. And if you're interested in this approach, if you want some supplementary materials, they are available on the links. thank you very much for
Thank you
attention.
very much for the presentation. Maybe one question, yeah, because the lunch is ready. Have you any questions? I have one. What do you think? It is possible to make a standard, such ISO standard for tables creation, for example.
Thank you for the question. I think that it is impossible because of any person is individual and he has an individual approach for table creation. For example, we had some tables as they related with thick bytes in Irkutsk region, and they were represented in Excel tables. However, we can't process them because of the very strange structure, and it was unable to get data.
Thank you. I think if we have more standards in informatics, it will be better for us.
Yeah, it will be better. Sure.
Thank you very much for a very interesting presentation. That's for you.
Thank you.
Thank you, Slawomir, for your work as a chair.
Thank you very much for a very interesting discussion for all of us. And I think lunch is ready.
Unfortunately, we hope that somebody is watching us because the presentations are broadcasted on the internet. And actually, we suggested our students and colleagues to have a look at them. And I'm very glad to present Maciej Laskowski from Lublin for presentation about color blindness detection and generation.
Yes. Hi, I'm Maciej Laskowski. I'm from Lublin University of Technology, and today I'm gonna tell you something about how to generate some color set to detect color blindness, and how to generate it, how to detect certain type of color blindness, and how to implement that method in some of diagnostic methods. Okay, so basically, I'll just walk you through the notions that I will be using during my presentation, because I'm aware that not everybody is aware of the fact that we have several different types of color blindness. So basically, we have three types of color blindness, except for total color blindness.
Look out for the equipment, because you can hurt yourself.
Okay. Okay, so we have proton color vision disorders, which are divided to protanopia, which means total red-green color blindness. So you cannot tell apart red from green, but you can see other shades of colors, and protonomaly, which means that you have impaired recognition between red and green. You may confuse them, but you can see a difference in some shade. We have also which is divided into deuteranopia and deuteranomaly, which is green-red. So you have problem with telling apart green from red, not divided to tritanopia and tritanomaly, which means that you have problems with differentiating blue and yellow. And I will stick to those three categories in the future. Color blindness can be caused by genetics, so it can be congenital, or it can be acquired. It can be acquired during some illness, to some trauma, to some intoxication. And what is important is that it may serve as a diagnostic factor in those illnesses. So it's optic neuritis, it's diabetes, it's age-related muscular degeneration, sclerosis multiplex, Parkinson's disease, and so on and so forth. So if your color vision is normal, and you start noticing that you have some troubles with telling some colors apart, it may suggest that you should go visit a doctor and run a diagnosis for example, glaucoma or diabetes or sclerosis multiplex, because it may be the first symptom that something is wrong. And that's why you should test yourself. But the problem is that color vision, the correctness of color vision, is tested only a few times during our lifetime. Basically when we are at school, basically when we are applying for the driving license, and so on. But the problem is that, for example, diabetes or sclerosis multiplex can be acquired at any time, right? So I can have my color vision checked at 20 years of age, but I can acquire diabetes at 40 years of age, and I won't be checked for color blindness or for correctness of color vision in that time period, and I won't be aware that something's wrong with me until the other symptom of, for example, diabetes or sclerosis multiplex kick in. So we need a method which will be easy, which will be quick, which will be cheap, and probably which will allow people to test themselves for color vision disorders. Of course, there are some color vision detected methods right now. Just a short overview. We got pseudo-isochromatic plates, so Ishihara plates, which you probably came across one or more time in your lifetime. We have spectral methods when we mix two different colors colors of light to acquire the third color. We have arrangement methods when we put some color samples in a certain order. Or we have lamp methods when there are lamps being lighted, and the testee should tell which color is is on in which corner. The problem is that methods are not 100% certain that you have some color vision disorders or not. We have two parameters which can be tested right now. Sensitivity means how many true cases are detected, and specificity, which means how many true negative cases are detected. And as you can see, we have some parameters of methods used currently, and we have amaloscope, which is 100% sure. The problem is that an amaloscope costs about 100,000 euros or something like that. So it's not a cheap solution. The equipment is pretty expensive. An amaloscope actually is that. So we have a certain light color, and we have to mix two different lights to obtain the third mixed color. I have no idea why it's so expensive, but nevertheless it is so expensive. So we can also of course say that okay, we are computer scientists, so we can make a digital version of those methods, but we have three problems. First of all, quality of implementation. So, for example, we take in the Ishihara plates, we are scanning them, we are putting them in some kind of application, but the colors on paper and the colors on screen will be different. Even if the method is correctly implemented, the implementation will have at best the same sensitivity and the same specificity as the original version. And the third problem is that we have a limited set of colors which is used for the diagnostic purposes, the same as original method. And that's why I came across with my algorithm for generating sets of colors actually, which may help in the process of detecting color blindness. As I said, we have some problems with the set of colors used currently. I'm not sure if you can see right now, but here's the whole color space, that half of ellipse here. The triangle here is the set of colors which can be displayed safely on the computer screen, is the RGB color space. And the gray area here is the palette of colors which is used for in Ishihara plates. And the dotted black line is the set of colors which is used in the Fanzel-Münchel color panel. So as you can see, we have a small subset of colors which is used currently, while we have a plethora of colors which can be used for detecting for color blindness detecting methods. So I came across the idea of quodlibets. Quodlibets from Latin quodlibet, what you like, what you feel like, what suits you. Pairs of colors which are hard to distinguish by a person with a certain type of color blindness, but which are easy to distinguish by a person with a normal color vision. The quodlibets are called confusion lines. Confusion lines are those intersection lines here, which show us which shades of colors are difficult to be told apart by a person with a certain color blindness. So here's the confusion lines for protons, here are for deutons, here are for the tritons. We have also the triangle of sRGB color space, so we can check the limitations of a color computer screen, and we have also the illuminant D65, which tells us the white point in normal light, in normal setting. The confusion axes are based on the observations made by Wright and made by McAdams, who discovered that even persons with normal color vision may have troubles with telling some colors apart. Sorry. This axis shows us the colors. The small axis here show us the colors which are hard to tell apart by normal people. But as you can see from here and from here, the direction of both axes are totally different. So people with normal color vision have some problems with telling this shade of blue from this shade of blue, while the person with, for example, proton vision disorders have problems with telling apart the difference between this shade of blue and this shade of red. So the directions are completely different. The problem is that color space, the CIE 9031 color space, is not perceptually equal. It means that the distance between colors here is different based on the color length. It does not represent the differences in perception. That's why we have to change to another model, the CIE LUV. And as you can see now, the axis here, the lines here are now equal, of course, equal to each other. So here are equal, here are equal, and so on and so forth. If we change the whole model to LUV, we can see that something is interesting. It means that we have the confusion line. I only now present you with the main confusion line, because I don't want to make this image unreadable. And as you can see, the confusion lines for protons, so the people who have troubles with telling apart reds from greens, is perpendicular to the main axis of people with triton vision disorders. It means that people who have troubles with telling blue and yellow apart won't have problems with telling red and green apart, and vice versa. Those dashed lines here are so-called residential hues. Residential hues means that those colors are easily to distinguish by people with certain color vision disorders. So, for example, blue line here, showing us the problem, the confusion axis for tritons here, is also perpendicular, or almost perpendicular to residential hues, meaning that people with triton color vision disorders will have problems with detecting this yellow from this blue, but they won't have problems with detecting this kind of green, telling apart this kind of green from this kind of red. So, based on that, we can also make it more visible with the perpendicularity here when we encircle it around the point of white, the D65 illuminant. So I started to think about how we can use the confusion lines to create a color set, sets of colors, which will be a nice tool, as a nice basis for some color vision detecting methods. And I came across also just noticeable difference. Just noticeable difference is an experimental parameter which tells us the difference between a confidence, let's say, between two observant colors. So if the difference is too low, so for example here, an observer with the standard color vision is not able to notice the difference between two colors. If the difference is high enough, the observer sees two completely different colors. So we have, as you can see, we have 5 steps of those two between colorblind people, partially colorblind people, let's say that, and people with normal color vision. So, the algorithm. I'm also almost running out of time, so I will just speed it a little up. We have 6 steps. First of all, we select a color vision disorder type. Then, so we decide either we are testing proton, we are testing deutons, or we are testing tritons. Then we decide if we want to test for dichromacy, so for complete color vision blindness at certain level, or anomalous trichromacy, which means that people are just partially impaired in color vision. The examiner selects number of quadlibets to be generated, and there is a point on the confusion axis which is selected randomly in the CIE LUV color space. This point have parameters of U and V, so we can say it's X and Y on the standard axis. Then we randomly choose a vector based on the area defined by just noticeable difference. So I select a vector from this area around my point, and then another point by offsetting my point A by that vector. So now I have A and B points, and those points represent two colors of my quadlibet. And my quadlibet, so the pair of colors is saved, and the scenario is repeated until all the number of color pairs is generated. The result looks like this. So we have certain colors here and here, and if you have normal color vision, you should be able to tell apart all the differences, maybe between this and this, because our screen is messing it up a little. People who have protonomaly, so have impaired red color vision, impaired, so they are able to tell some differences. They are able to spot the differences between those two colors. And in case of protanopia, so full color blindness, people are not able to see differences between those two colors. So they have a 50% chance of making a right choice. Of course, we won't test them with only one pair of color, but a set of pairs, so the probability of randomly guessing which color is which is relatively low. My algorithm, in theory, allows to generate almost any combination of colors which can be used for color blindness detection. It should be noticed that even if somebody is currently detected as a colorblind person, currently used tools for detecting color blindness are not very effective right now. So even if I am detected as colorblind person, I may be able to tell some of the shades apart. So we should verify which number of pairs, of color pairs, is enough to be fully aware that somebody has color blindness or not. But as I mentioned at the beginning, I think that this algorithm should be used mainly for self-testing. So, for example, I have a risk of diabetes, so I'm testing my color vision at fixed dates, for example, each week or each month, and I'm able to monitor if my color blindness is my potential color blindness is kicking in or not. This algorithm served as a basis for several different tests conducted at our university, but that's another story. And as far as I can tell you right now, the results are promising. So I have the pretty good rate of detecting color blindness, sometimes even better than currently used methods. But it's another story and another paper and another presentation. Okay, questions, comments, remarks?
First of all, thank you, Mathieu, for a very nice presentation. I hope that we will have some questions from the audience.
If not here, maybe after the session, it's not a problem.
Because I think that we have some minutes left.
Okay.
So, any questions? Well, so then I would like to have some remarks because I was very impressed, and I don't think, well, first of all, Mathieu is not the first, and the term of just noticeable differences is extremely well used and widely used for medical monitors calibration.
Yes.
It's how to say, how to say, the basis of DICOM standard part 14. How to say, that side, for example, about the equipment calibration would be very, how to say, it is, the equipment calibration is very necessary. Well, we just were observing that the worst
case
visualization case.
Yes, of course.
To be enough. Well, and well, the question is, well, so you mentioned about the promising results. So, how many people you have already tested?
Okay.
Can you give some ideas about?
Yes, I smoothly jumped over the problem of calibration of the screens, but yes, it is an important issue. And before even attempting to test somebody for color vision correctness or color vision disorders, we have to calibrate the screen, so we are fully sure that the screen is not a problem, right? Because as you all noticed, even with perfect color vision or a good color vision, as not calibrated screen can mess everything up. So that's the first let's say answer to your remarks. But speaking of experiments, I've conducted tests on over 500 people right now, and the results, as I mentioned, are promising because about 10% of people were detected as people with some kind of color vision disorders, which is the normal group or subset, let's say, of people in the whole population. Color blindness also, which should be mentioned, but it's as we are speaking, let's say, a little off the record. It's not politically correct. Why? First of all, it affects more males than females, because the genetic basis of color blindness is the chromosome X, which means that women have two X's, right? So even if one chromosome X is damaged, the second one will do the job, and they will have the good color vision. In case of males, we have X and Y, and if X is damaged, we have nothing left. So that's why it's a little different. And secondly, it affects more people who are white than people who are Asians or who are black. I have no idea why. Basically, it's genetic basis, but I'm not sure about the results. So, considering European population, the group that I have detected that they have color vision disorders are statistically the same as it is known. First, that's the first success, and the second success is that some people who were examined by doctors for the medical license and they were told that they have a good color vision, went through my test, and they were detected that they have some troubles with color vision. They are, for example, protoanomalous or deuteraanomalous. And I have tested them by the medical doctors, but using more efficient methods, using for pilots or for truck drivers. And I was assured that my diagnosis was correct. So the first diagnosis was wrong. The first medical diagnosis was, let's say, maybe not wrong, but not as correct as mine. So my method for now on has a better sensitivity than Ishihara plates, which are the most commonly used method of detecting color blindness right now. Of course, 500 people is not a statistically, let's say, significant enough group to brought about that I'm better than the methods. My method is better than a method which is used for over 100 years. Right now, or almost 100 years, but nevertheless it gives me some light at the end of the tunnel that my research has some future and may be implemented in some medical tests or some applications for self-testing of people.
Thank you very much.
Thank you.
Thanks again for Maciej Laskowski. We have a certificate for presenter.
Thank you very much.
So thank you very much, and we wish success in future investigations.
Thank you. I will, if I succeed, I will present them right here.
Okay. We will hope. Well, in let's say a year or two. In a year or two.
Exactly.
Maciej will coming back. Well, and the second presenter is Professor Jerzy Matusewicz on the rowers motion captures. Please, the floor is yours.
Mr. Chairman, I wanted to present a paper called Analysis of Selected of Rowers Posture Using Motion Capture, a Case Study. I represented the Institute of Computer Science, Lublin University of Technology. My English is not very well, so my friend with Institute, but I think that you understand what I wanted to tell. For a few words about motion capture system. It is a modern technology of 3D motion capture for obtaining a digital representation. It analyzes the development of player skills, and it used digital processing of qualitative and quantitative data. This system we have two aims of our paper. Calculation of the angular position of the back, and second aimed of value of the player's effort while overcoming the distance. For the available article, different authors using the different biomechanical models with 14 or 21 markers, different system of motion capture, and different ergometers. Our test stand has three important elements. Optical system with 8 infrared cameras, one concept to ergometer, and pulsometer for message heart rate. In our research, we study of an ergometer rover is a performance test. We use own procedure used for the calculation, and the procedure consists for 4 stages divided to several steps described in a work by the authors. In our research, we use the biomechanical plug-in gate model. Was used 39 markers. We added two markers, name S1 and S2 on the spine in order to better examine the subject posture. We have 2 players. One of these is players from Academic Sport Association, and another is the amateur. They have a similar body mass index. At the start, we did a preliminary test on a person rowing along the distance of 100 meters. On this basis, it was assumed that the optimum resolution values of the infrared camera will be 100 Hertz. We had two independent attempts at rowing. The player always aimed to minimize the time of overcome the distance. In the first attempt, the subject rowed over a distance of 100 meters. Next, the player had a rest for 3-5 minutes. And the second attempt, the rover overcame the distance of 500 meters. During the study, the movement of the rover was recorded. After passing each 100 meters distance, the following parameters were measured: the rowing time, heart rate, number of moves, and the power of the rover. We study 4 different phases of the angle called P1, P2, and P3. These 3 phases over the stroke movement and phases called P5, the steps of a return movement. This table shows results of a ergometer and heart rate monitors. I wanted to point out the red and bold numbers. After traveling for 300 meters, the generated power significantly drops from value 335 to 267. It is drop about 19%. The number of stroke drops from 41 to 29, which means that the polling phases is extended. In the second table, we see average value and standard deviation of the inclination angle of the back. The data in the table show that results from first row and second row are similar, which means that player was not tired. When we compare the second round with sixth round, we see that results are different, which means that player was tired. Okay. The next slide see the average values and ranges in degree of the angle of a back's inclination over distance of 500 meters. Each point means a distance 100 meters. We have 4 phases: P1, P2, P3 and P5. The greatest volatility was observed for position from 6 to 25 degree. The results obtained shown that from the distance of 300 meters, there is a growing rover fatigue. In this figure, we see the average value of ranges of the angle of a back's inclination over the distance of 2 meters. And now we compare results for non-rover, and this figure clearly showed that significance of difference in performance values position P1, P2 and P5. We obtained result for position P3 corresponds to the test carried out by Sforza, who stated that the angle can reach even 120 degree. And this figure, we see the average value and ranges of the angle of the back's inclination over distance of 500 meters. The values of these angles is the case of rover and stable, or changing them is not significant for position P1 and P5, which means that rover was not tired, but non-rover was tired, and his technique got worse. In this slide we see the result for P2 and P3 position. Analyzing of the result relating to a non-rover shows that in all positions of a subject and at all distance of a back's inclination was significant. The result angle values were significantly different from those obtained by a rover, but the non-rovers more so. This is rover, this is no rover. And for the end, from this paper we formulated 4 conclusions. Calculated values of the angle of a subject back obtained from the data recorded by the motion capture system for the proposed position P1, P2 and P5, and the quantitative analysis of partially overcame distance can clearly distinguish the contestants' level of training. Changes in the angle value of the inclination of a back for a non-rover significant for all analysis position at all partial distance and property reflect subject's state of fatigue and technique differences in row. The third, data from the motion capture system property correlate with the value from the egomet and pulsomet, which allows to draw valid condition of the rowing skills of the subject. A non-rover state of fatigue and turning the pretty anaerobic stage of exciting occurs after covering some 300 meters of the road. The research was approved by the Commission of Research Ethics, and this is the end of my speech.
So, thank you, Professor Kusevich. Any questions from the audience? So, then I have a question. You mentioned, so what should be the, how to say, the range of rowing for the professional rower? Perhaps much more than 30 meters, perhaps also. So to reach the same results, to see that the rower is tired and maybe then it is his technique is degraded. So have you tested? It might exceed a kilometer, perhaps.
This is the first research for us, because we have a motion capture system only in second years, and we now learning using this system, and we wanted to correlate, jak to było heterogeniczne? Heterogeneous sygnały.
Okay, maybe I will translate it better. Mi powie po polsku.
No, że chcemy badać heterogeniczne
sygnały z pulsometrów,
z różnych elementów, które można, z różnych urządzeń, które można przyłączyć do zawodowców, prawda? Ale żeby ten jakby...
Sprawdzić, czy to się nie zakłóca, tak?
Nie tyle, co nie zakłóca, to jest pierwsze, ale że chcemy, żeby te różnice zmierzone przez motion capture były możliwe do procesu treningowego użycia.
Okay. So first of all, we are trying to research the heterogeneous signals. So, for example, from the pulsometer, from the ergometer, from the motion capture, and so on. So we will be sure that there are no distortions between those signals. And after gathering the data, we want to ensure that it will help in improving the training process of that person. So first we need to ensure that there are no distortions, and then we will be able to measure the improvement in the future.
Badamy jeszcze sygnały mięśniowe, prawda? Zmęczenia mięśni, tutaj EMG.
Oh, yes, the pulsometer, the ergometer, the motion capture, and EEG, so the muscle tiredness or something like that. We can measure the tiredness of the muscle.
So, thank you very much, and I'm glad to present the certificate for thank you. And let's continue the e-health session, and we would like to invite Toma Rusinaitė for the hospital information systems applications and process improvement.
Hello, I am Kaunas Rusinaitė, and today I speak about improving business process in HICE by adding dynamicity. Dynamic patient treatment process are usually human-centric and often unique. Implemented patient treatment processes into information system should be capable to adapt dynamicity according to the real patient treatment process change at process announced as dynamic business process. Dynamic business process modeling, simulation, and execution has been activity investigated over the last few years, but not existing approach to dynamic business process modeling, simulation, and execution have been incomplete. So, research related to dynamic business process is becoming more and more important for the past several years. However, concept of dynamic business process still has no clean, unified definition, and authors proposed different definitions of a dynamic business process. So we have made analysis of dynamic proposite of business process. And we proposed 6 requirements for dynamic business process, which you can see in this slide. Also, we propose, according to the requirements, we proposed 2 definitions a dynamic business process as process which support change to any process components, which is not predefined and could change at runtime according to the change of context or rules. Also, we proposed the dynamic business process model, which support all requirements. Business process in hospital are changing due to changes in the environment of business systems, new treatment methods, and new law enforcement. These changes should be implemented very fast because it is necessary to adapt in fast-changing environment, maintain competitiveness, and improve quality. Usually, it requires a lot of research to implement new changes because usually it is needed to not only to reprogram the software, but also to change the business process components, activities, business rules, or decision notes. It is this description that the changes implemented the business process runtime in order to execute the dynamic business process. Vilnius University Hospital Santariškės Clinica is one major hospital in Lithuania, encompassing the provision of medical care in almost all the areas, converting practical and scientific medicine, education of students, residents, and visitors. By developing modern information system, improve medical service quality and accessibility, create effective and reliable working environment, provide opportunities for medical research and development. In this slide, we proposed main architect of hospital information system. Actually, the system is component 2 parts. One part is modern, and next part is legal. So the institution has developed a hospital information system which integrate electronic laboratory image and next page. It is just one page architecture, and next page is this. it's two parts. This is a simple, it is a process of stationary and ambulatory care. We have two types of patient, in-patient and out-patient. If is in-patient is this process part, if out-patient is this part. If if is out-patient, this activity is detailized and it has sub-process. This is it is example. If process patient is in patient, he and he do next activity. If patient is out, he need to do more activities, and the process is along. In this an example paper version of medical treatment, which is used in many hospitals in Lithuania. It's one example, and next. But we had a goal to implement fully components system and stop to use the paper for at all hospital, because it is complicated for doctor to approach all the need medication for patient. For example, the treatment schemes are very large, and medical treatment schemes have a lot of configured process, like age or age script stage. This is an example of configured formulas, which used for calculation for medication dose. This is system form. Doctor choose treatment groups after treatment schemes, data, and he research dynamic properties of the patient, for example, age or next information, and he accept, and he can see all information about patient. And this scheme is made automatically according to patient properties. This Windows is used by nurse. If something change, patient she can see about this patient. If if patients eat bad medicament, she can see that it's bad. And results. During these activities, 12 treatment groups and more than 300 unit treatment schemes were developed. 2,600 medication used in scheme, 1,400 setting for the treatment schemes, were configured. More than 900 unit patient was registered from the July till April. More than 90,000 medication was given to the patient according to treatment schemes. Thank you.
So, thank you very much. I would like to encourage audience to give some questions. Yes, please.
You are measuring different parameters of the patient, the height, the serum weight, and so on and so forth. And then you detect how much medication should be given to the patient. But do you change it over time? For example, if I'm 110 kilos right now, if I go to the hospital for a month, probably I would drop to 100, I guess. So,
usually,
nevertheless, my weight changes, right? So the amount of medicine, the dose of the medicine should also be different at the start of the month when I'm 110 and at the end of the month when I'm 100. Probably I should be given the same dose with the different weight, right? So do you monitor the changes of patient parameters, so you change the dose of the medicine over time, or just
all the time?
All the time.
Yes.
Okay, because it looked.
It is not just one time. It's if you eat one medicament and it is bad. For example, if you feel very bad, doctor change, and in the system you can see all time.
Okay, but the doctor has to change manually, so the system does not compute that, oh, he weighs 110 kilos, so he should be given 10 grams of that medicine, but now he weighs only 100 kilos, so he should be given 9 grams of that medicine. So the doctor changes it manually, right? The system does not compute it automatically.
As I remember, I guess I heard how they talk about it. In the system, they change weight of person, and system automatically calculate the dose of that medicine. So basically, you change the weight of person, but you do not change amount of medicine.
Okay, thank you.
Thank you very much. And I'd like to present present the certificate. So, thank you very much. Well, and the last presentation is of the session will be done by Vera Chendik.
Just minimize this. Okay, thank you.
Hello. This figure depicts the typical architecture of the distribution grid with renewable energy sources in a small neighborhood house, compression of the few households with possible commercial industrial activities, farms, workshops, etc. Here, energy is generated using sources such as photovoltaic elements, solar panels installed on the roofs of the houses or nearby land, and wind turbines installed where it's suitable. Energy is stored in the energy storage bank for the future
use. Additionally, grid is connected to the internal power grids, which can serve as both a source of the additional purchase energies and sink to where supplies energy could be supplied and potential sold for central price. Planning, design, installation, and operation of energy grid are all complex tasks and shall be performed phase by phase and considered in total context from request to energy. Here, request formal or informal is input to planning phases and has to be translated to the requirements during planning time. Design phases is accepting requirements and has to produce drawing, a set of installation technical documentation during design time. Similarly, installation phase is production working system during implementation time. Operation system is producing energy during operation time. Operation characteristic of the target distribution grid are pretty much defined steps of planning, design, and installation. Thus, as in many other cases of design, which complex system, we have to start from the requirement analysis. Having clear target defined in the requirements, we will allow to translate them to the operational parameters, and this will enable modeling of the system which are appropriate tools before starting of the design. Thus, it may be convention on to use decision support system which can take to some user tasks. In this study, decision support system is proposed to solve the problems in the stage of planning and designing. The result are feasibility study of parameters of optimal system configuration that satisfies energy needs and in the minimum period covering the installation cost. The goal of this study is increasing the effectiveness of decision rejected electrification of buildings using renewable energy sources by development of models of support making decisions under unconditionally. At this slide are present objects and subjects of study. On this slide you can see the task of study. To summarize an idea about the relationship between the stages of information processes in decision support system was decided to do functional modeling of proposed in this decision support system. As such, processes were allocated, connection and processing of information, formation of requirements to the amount of required energy, the calculated of various of energy system configurations, the task of optimization of the choice of configuration and cost analysis form a feasibility study. Decision support system at the design of distribution energy systems with renewable energy sources contains next components: the set of preferences of the person who makes decisions, the set of software, the set of tasks are performed in this decision support system, the set of databases on which decisions are made. On this slide you can see the main task what the decision support system is solved. On this slide is presented the scheme of interfaces of this decision support system components for decision distribute energy systems, which include the relationships between the constituted parts. It was determined to use such information models. The subsystem of connection and preliminary data processing, gathering information on weather condition, technical and economic performance of the equipment in the internet. Data is storage of SQL database and used in other modules. The subsystem of analytical processing is divided into two parts: geometrical information system of the region, the creation of grid and weather maps of areas. Data is stored in its own database. Modeling the slab simulation of the work. Data storage warehouse based on data storage in SQL tables, GIS and MATLAB. The subsystem of making decisions, the generation of alternative decision solution, evaluation and final formation of the optimal solution. The data is obtained from the data warehouse. The subsystem of presenting result web interface is used through which users receive access to the system. In addition to the established decisions, a user can see GIS of areas. This map provides opportunities to compare lengths for building described grid with the potential of renewable sources. Thus, it can be chosen the best location for building grid. The result of use of multiply information system causes that architecture of developed decision support system should provide consideration of information hierarchical ordered of parts and aggregated information while transferring it to the upper levels. The subsystem of making decision is almost doesn't work with details data and mainly used aggregated data that are calculated on the basis of raw data. Among the method of data storage, the structure of data warehouse allows in best way to control this situation. In other case, the data warehouse is recorded, aggregate information are calculated in MATLAB. This allows to store the quickly access aggregate information in conveniently way as calculation in MATLAB and storage in text files, which is disadvantage for further work with them. Listed subsystems are controlled by different servers: web, GIS, MATLAB, Microsoft SQL Server. As the final integration method is used integration at the level of data warehouse. Integration data are used in subsystem of making decision and results presentation. To select the optimal configuration of system element is solved the optimization problem with using the method of parite compression. The criteria in this case include planned investments, the payback period, meeting the needs in power generation, cost of the repairs and replacements of equipment, expenses of equipment maintenance. System configuration are defined according to the model in MATLAB Simulink subsystem. Total energy balance in the energy grid is shown on the figure. Here different energy required, as well as source and parameters influencing need to phases of opportunity to set energy. This model is used when building a simulation model of the grid and part of the subsystem of analytical information processing. The realized simulation model in Simulink is presented on the slide. To determine the energy generated by solar panels and wind turbines is used top-down approach. Of the first estimate resource potential available in the region, then this value is restricted by technical characteristic of equipment. The power of electrical load are required by consumers is based on probabilistic and statistical models. According to this, for energy use of supply within grid or between distributed grid and external grid could be as follows. Requests from individual households to grid for satisfaction domestic industrial use, from power bank to distributed grid, external grid to recharging, from distributed grid to external grid to purchasing extra energy of satisfying domestic industrial use, for the distributed grid to external for selling of the surplus energy, for external grid to distribute for buying of the supplies energy. We assume that power requests are coming as random sequences of events. Each type of request is in general is characterized by its discrete time, final time, length, finite energy associated with the request, power, volume, priority, and costs. Operational logic of the hybrid electrical system is presented in figure. Here is some simplicity are omitted instant discrete values of time, request power, priorities as well as costs, and only generalized value of request from household is used. It is important to introduce the logic for purchasing and selling of the energy from to external grid into the overall operation scheme of the distributed grid rights from the design phase, because adding it later to the live system could be problematic, as the temporary measures for some fixed default price can be allocated per energy unit, which can be later and assigned to the realistic floating market values. The deficiency of power supply probability is defined as the sum of the deficiency in power generation by distributed grid, sum of the required extra energy during the given time period as a ratio to the total sum of the energy request from households. According to the operational logic, previous slide, is energy generated by distributed grid exists required amount from households, then the excess energy is accumulated in the power bank until reaching its maximum value. After that, this exist can be sold or excess power generation by the grids is defined as the ratio of the total excess power generated by the grid in a given time period to that of the total sum of energy requests. The objective function of the optimum design problem is the minimization of the cost of energy. The objective function of the optimum design problem in the minimization of cost of energy is an economic evaluation tool for the energy production in integrated system, which included all recurrent and non-recurrent cost over project lifetime. It is defined as the ratio of the total electricity production by the system, in opposite to the annual electrical production historical data. The annualized cost of system is the sum of the analyzed capital cost, the analyzed replacement cost, and the analyzed maintenance cost of all components of system. Maintenance and replacement cost occur during the project life, while capital cost occur at the designing of the projects. Present functional modeling of the process in the decision support system on the stage of planning and the design of distributed energy grid proposed the model of this decision support system in planning energy grid with using renewable energy sources and approach to determine of optimal configuration of the system in the central condition in the multi-corporation of alternative of energy grid. Determined the formal formation of decision support system custom warehouse, proposed model of creates influence to the decisions. Thank you.
Thank you very much for the presentation, which might be in such conditions when energy prices are rising up and up. So maybe it's even more interesting for everybody of us than e-health. Well,
what can I do?
Well, maybe somebody has questions. Actually, indeed, if this decision support system is suitable for some houses or not that.
We can use the system, support system, on the phase of the construction of energy system for the some of building like this, like as street of the or micro region of the town or village, small village.
So, have you some test implementations already, or not yet?
Not yet.
So, thank you very much.
Thank you.
Well, I would like to give the presenter a certificate. Well,
Thank
you.
you.
And well, thank you all for coming to the session. Well, we are closing it, and I would like to invite you for the coffee break, which the coffee will be served not only on the 5th floor near Čiurlionis Hall, near Nichelle Hall on this floor. So also.
Yes, we have 2 coffee break places, and I'm on time. Thank God. Yeah. Thank you, Dennis, for the
even me.
Session. Yes.
Thank you very much.
To you. And now we have some time. I think we have about 5 minutes to coffee break. So we still can go out and grab some snacks.